Hello everyone, welcome back to our premium course. Today I will show you how to add restraint to beams. This is a very important topic, how to add and edit a restraint on beam. Yes, there are three ways you can add restraint on beam. The first way, you can add during modeling of beam. Yeah. We correct the option and input the vector. So this way it is easy for the during modeling stage. And the second way, you can edit it. Yeah, edit it by right click and edit on the property to edit the parameter, yeah, on the restraint. And the third way, you can add restraint after we run analysis and design. You can now let me zoom in. Yes, you can review and show auto state and set the restraint. This way only valid when we have a beam and sub beam. Yeah, we model the beam, the main beam with the sub beam or purlin intersect each other at any point, so you can select and set the intersection point at the restraint at the top or bottom together. This way valid only when the modeling complete with the intersection of the member. Okay, for the first two methods we can add without the intersection of the member. Now let me start the first method, how to add restraint on the beam. Yes, come back to our Tekla Structural Designer, and now let me delete this model. Click OK. Again, come back to the structure and level base, and click on the modeling. Click on the beam, steel beam, and select the section. Now use IPE 200 and lateral restraint, and take the top plane continuous restraint because we designed it as a steel beam, yeah, non-composite steel beam. So I untick the option. I explained you previous tutorial. You can see more detail about this tutorial and ask me a question if you understand or have a conflict about this explanation or about the previous video. You can ask me directly. I will explain you. And you see here is the top plane vector, the lateral restraint, and the bottom plane. Now let me, yeah, bottom plane continuous restraint and strut restraint. What is different between those two restraints? Come back to the document. I explain you everything in the document for more detail. Yes, what is different between strut restraint and lateral restraint? Yes, strut restraint and lateral restraint in Tekla Structural Designer. Strut restraint are usually member which are coming into the measure or linear axis. The blue narrow, yes, the blue narrow, and contributed to the compression buckling. Like you have a column and you have other beam connect to this column in the direction. So this type of the connection between the beam and the column, you can assign it as the strut restraint. Yes, strut restraint. And the lateral restraint and the member with restraint the flanks and contribute to the lateral torsional buckling shake. Yeah, when you press at the flank, yeah, the bottom and the top flank, the screen narrow. This is the lateral torsional restraint to prevent lateral torsional buckling occur on the member. Yeah, understand or not? Lateral torsional restraint. Okay. Now come back. For the lateral torsional restraint and strut. This for the lateral torsional restraint. Okay. Now, in the case you want to measure, yeah, to measure. Now let me come back and show you example. Yeah, in the first example, we has a main beam. Yes, main beam, and has the sub beam at the middle of the main beam. So this sub beam, we can assign it at the restraint of the main beam. The torsional restraint also depend on the connection of this sub beam. Now do not detail about the connection, but we assume it as the restraint to prevent lateral torsional buckling also for the main beam. Okay, now let's come back to Tekla Structural Designer. The option, we only measure the main beam without the sub beam, but we input the option to correct the option in lateral torsional restraint. At the top, change the factor to 0.5. 0.5. Yes, and at the bottom also the same 0.5. Again, yeah, 0.5. Okay. Now let me measure. Yes, 0.5. Let me measure first point and second point. Enter. Escape. And click on the support to assign support. Again, click on the 3D. And come back to the load. Click on the dead load. We assign dead load 2 kN. Load. Again. 2. And assign light load 4 kN. Okay. Complete. Come back to the base level and you can use the window selection, right click, copy, click first point and second point, again click on the beam, copy, second point, click on 3D, click on edit, copy load, impulse, click on the first beam, click on second beam and change to the dead load, copy, click on the first beam and second beam and show the load, dead load, click on the load and select on type. Yeah, the magnitude of load is 2.0 kilonewton per meter. Yeah, 2.0 kilometer. Apply on the beam. And now let's click on the impulse. Yeah, 4.0 kilometer. Apply on those two beams. This beam we change the restraint, yeah, we add the restraint at the center of the main beam is 0.5, 0.5. Okay. This is the length of the beam. The total length of the beam is 6 meters, and the sub beam, yeah, intersect at the length at the 3 meters. So we assume it as the restraint of the main beam. This restraint to prevent the lateral torsional buckling, and the LTB is equal to 3 meters, yeah. And the factor is equal to 3, yeah, 3 length. The length of the restraint is 3/6, so the factor is 0.5. Come back. Now this beam we do not use the restraint. Okay, change it to where is the restraint? And check auto option, yeah, and check auto design option. We do not want to automatically update the section, which I want to check and verify. Escape again, click on the beam. Now we can change the option. Now let me click on beam again. Yes, you see here the release and restraint, lateral restraint. Escape. After you modeling and copy, now let me check on the option. Release window. You see here we cannot change it. Okay, we cannot change it. So after you choosing modeling, you click on beam, you can change it directly in the option lateral restraint and strut restraint. Strut restraint we apply for the compression buckling, and lateral restraint apply to prevent lateral torsional buckling. Okay, again. So now to change it, we use the second method. The first method we use the restraint during modeling a beam. So the second method, after you modeling a beam and you want to change it, just right click on the beam, left click and edit on the member. Click on the restraint, lateral restraint. You see here the lateral restraint is 0.5. Now let me change it to 1. So this beam there is no restraint to prevent buckling, to prevent lateral torsional buckling. Now type 1, enter, and this one type 1, enter. Okay, this is how you can correct the restraint just using second methods. Okay, now let's run analysis design to check design. Okay, check it, the result is 1.074, and if one the result is 1.672. This beam we design with the restraint at the center. Okay, the restraint at the center of beam. There are two sub-restraints connect each other at the center of the main beam to prevent lateral torsional buckling occur on this main beam. This is the concept when we apply during the modeling stage of the beam, and the second concept we can change it by using edit property. Now in this beam there is no restraint applied on this beam. Yes, no restraint. Okay. In the last beam there are two restraints applied at the center of the beam. So the vector, the ratio is 0.5. Yeah. The vector is equal to 0.5. And this beam, no restraint. To prevent lateral torsional buckling, LTB, lateral torsional buckling. Okay, understand? I hope you understand my explanation. If you have other question, can ask me directly in the group. Now let me click delete it all. Come back. For the first way, how you can change the restraint, and the second way, how you can change the restraint. Click on the, come back to model, click on the base, the wall. Okay, now let me correct this model by using the third methods. Third method, how you can add restraint on the beam. Okay, now let me click on the model link. I click on beam again. Keep the section IPE 200 and the top plane continue and take it. And we do not apply any restraint to prevent lateral torsional buckling and buckling. Now let me click on the center again. Click on 1, 2. Okay. Copy. Edit. Move. And click on the model. Support 1, 2. Click on 3D there. Yes. Now we add the sub beam. Yeah, there are two sub beam intersect each other with the main beam at the length 3 meter is 0 meter and 3 meter and 6 meter at the center of the main beam. So it's similar with this beam. When you model a beam without a sub beam, but you can edit the option during modeling to correct the lateral torsional buckling factor on the main beam. Okay, now let me click on the design again and click on design all. Now let's check the ratio. If 1.004, yes, if 1.074, it's similar because this beam resists more load from the sub beam, so the design ratio is lower than this beam, the less beam. We apply only the factor without add other load from the sub beam. Okay, the concept is the same when you apply the factor during modeling and when you apply the sub beam to correct the retrotorsional restraint. Okay, this is the first way and the second way, and the third way. Yes, this one the third way. The first way, you can add restraint during modeling, and the second way, you can edit it directly in the property. Okay, in the property. Okay, so now let me continue to the third method, how you can use the option. Okay, now come back. Okay, right now I want to focus only one method and second method, so I want to correct this subbeam. Okay, let me click on edit and move. I want to move it to the 1/3 or span. Okay, and click on copy. Click on the copy again. Yes, delete it. 3D. Yeah, it correct or not? Now let me check the dimension. (1.5), 3.5. Two is correct. Yeah. 2 and 5 is not correct, so you must to move it. Edit, move. Yes. Come back to model, click on dimension. Yeah, it's correct. 3D. So in the case, I want to change the vector to design are the same with this main beam. There are 4 subbeam. Yeah, 4 subbeam intersect in the length 2 meter and 2 meter from the end and from the start point of the beam. So now we have to correct it in method 2 by right click and edit the property. Again, lateral restraint we add to prevent lateral torsional buckling, and the strut restraint we add to prevent the compression buckling. It is clear, and come back to lateral restraint. And now let's change the sub-beam top flank vector and the sub-beam bottom flank vector. The vector now is you can use 2/6. Now let me click on the Excel. 2/6 is equal to 2 meter over 6. So the restraint factor is 0.33. Now let's change it to 0.33. 0.33. Okay, click OK. Yes, this beam and this beam is similar in the term analysis and design, but the result has a little bit different because there are 4 sub-beam at more load on the main beam, so the design capacity of this main beam has lower than this less beam. We input only the vector but ignore the sub-beam vest on the main beam. Okay, now click on the design again and click on run analysis and design. Come back, check the result if 1.04, and this one is the same if 1.04. Now let me check the design report, check the member static, and the buckling, lateral torsional buckling design, you can check. Yes, the length is 1.98 meter. Yes, 1.98 meter, because when we apply this ratio is 1.333333. We apply this 0.33 is equal to 0.33 multiplied with 6 meter. Yeah, it's only 1.98 meter, not equal to 2, but it's not a problem because it little different. It's around 2 centimeter for the restraint. It's okay. Yes, it's 1.99 meter is correct for the restraint. And design for the measure is apply moment 40.5 kilonewton per meter, kilonewton meter, and the restraint is 35.6 kilonewton meter. The design ratio is 0.88. There are warning, just warning, it's okay. Yes, the warning, but it's okay. And this member for we call the deflection on impulse load. But now we just verify for the moments and for the buckling, lateral torsional buckling. For the moment, it's okay. 40 apply the moment is 40.5, and the restraint of the section is 31.9 kilonewton meter. The design ratio is 0.78, and for the lateral torsional buckling, the design ratio is only 0.88. Okay, now come back and check the right beam. Right click, check static, check on the lateral torsional restraint. Yeah, this one is correct, is 2 meter. For the less beam, we apply the factor, they are a little bit different. It's 1.98, and the right beam is 2 meter, and design value is 81.8, and the buckling restraint is 84.4. So the design ratio is 0.941. And for the moment measure, the design ratio is 0.87. Yeah, 80 and 7. Yeah, everything is okay right now. This way, how you can correct the factor. Use the factor, correct in property, edit the property, section property. You can correct the lateral restraint. And the second way you can model it as the sub beam. Yeah. You see how you can apply the restraint using the modeling stage by correct the factor, and the second way by using edit. Yeah, edit property, and the third way you can by using the modeling. Okay, the modeling. Now let me continue to the final way, the third way, how you can correct this beam, a restraint. Yes, click on the design, again come back to the design, via design. So the status, yes, the status, the ratio, click on show alter stage. Okay, so alter state, a general attribute change, and find the restraint. Okay, find the restraint. Okay, and mode you can review this beam. There are restraint on the top. Yeah, but on the bottom there are no restraint. If you modeling this beam as the sub beam to prevent lateral torsional buckling on the main beam, you can add on the top and on the bottom restraint. It depends on the connection of the sub-beam into the main beam. Now let me click on the restraint type, lateral restraint. Now you can check with the strut and check it with the lateral and substrut to review lateral. Okay, now let me click on the set. Use the option to set the restraint where the main beam and the sub beam connect each other or intersect each other. Use this method only when the modeling their main beam and the sub beam intersect each other. You cannot use the option to assign on the single member. Yeah, the single member they are to way using the modeling and correct the factor, and the second way by using the edit property. Now the third way we can correct it in different restraint by using set option. Yeah, set, and restraint type change it to lateral to prevent lateral torsional buckling, and restraint we assign it at the top and the bottom. Okay, now let me click. Okay, correct. Okay, complete. Design again. Click on run lazy and design. Now check the ratio. Yeah, it's correct. Right click, check static, and buckling. Yeah, the lateral torsional buckling is equal to 2 meter. 2 meter is correct. This is the way how you can use the three options. The three options in the third option, you have to model the main beam with the sub beam, and you can change different type of the restraint by using the option to set the restraint. Again, so alter stage, restraint, set. You can select to set the continuous restraint. Now I want to change this beam to fully restrained. You can change it. Yeah, you can check it. Okay, you see here the different color. This beam is unrestrained. Yeah, unrestrained. This beam is unrestrained. This beam is restrained at the bottom. Yes, untick it. I hope you enjoyed the tutorial. For more questions, you can ask me directly in the group how to change and how to add and how to correct the restraint in the beam. This is very important when you modeling a beam. You must to understand about the condition. And for the bottom and for the top, you can come back on the structure and show the side, narrow side, the direction, to make sure this one at the top. Yes, this one is the top plane and this one is the bottom plane. You can check the narrow side on the top plane, and when you rotate the section, so the narrow side also change. Okay. Yes, now it change this one to the top and this one to the bottom. Come back. Now I want to keep it in the default. I hope you enjoyed this tutorial. Thank you for your watching. Thank you.